Well, hi there. Thanks so much for showing up for your math learning. It's your humble servant, Mr. Jennings. And aren't you glad that we're back to new content, everyone? We are in Unit 4. That's 4 out of 6 or 7. Okay, we will do 6 or 7 units. And so we're past the halfway point. We're right where we need to be. And we are into trig. Oh, what a lovely time to be alive, everybody, because trig is fantastic. And today we're learning like the big change in grade 12, which we're introducing radian measure. Remember when you used to get the wrong answers on your calculator and used to say, but why? I did it just like you told me. And it was because your calculator was in radians? Yeah, we're actually going to do that on purpose this time. So instead of measuring, say, an angle like so, okay, I've got this angle here. And instead of saying that that's like 30 degrees, we're going to measure it now in radians, which has to do with the length of this arc. You're going to love it. Decide you love it, okay? And then you'll maybe like it a little better than you otherwise would. All right. So what are we talking about? We're talking about radian measure. Radian measure, usually, like for most of the population, they talk about angles in degrees. They say this is 90 degrees. They say this is 45 degrees. This is, 180. And people are comfortable with that. We have a lot of like things like, oh, he did a total 360 or that conversation took a 180 or whatever, Right. But we're going to learn this new way because oftentimes it's advantageous to express the angle as a pure number without units, okay? When you talk about like 30 degrees, that's a unit, okay? And radians don't have a unit. And that can be advantageous, okay? And it's more convenient. All right, so 1 radian. What does that mean? If I say that, like, say this angle equals 1 in radians, well, what it means is if this radius were 1 long, like let's say that's the 1 hour distance that it takes an ant to walk from here all the way to here, then that same ant, were it to walk from there around to here, would also take 1 hour. Like this red distance is the same as this distance, sort of stretched around the outside of the circle, or wrapped, I guess would be a better word. So that's what we mean by radian. So we're measuring the arc length in terms of the radius r. Okay, so yeah, all of that. So what if we did a full 360? How much is that? Well, if we went here, that's about 1, and then that's about 2, and that's about 3, and we'd be almost across the circle, because that there, friends, would be 3.1415. Why'd I put a little dot there? 92 dot dot dot. All of those pi digits, okay? Half the way around a circle, that would be 180 degrees. Why? Well, remember in grade 5, maybe, where we talked about the perimeter of a circle was 2 multiplied by the radius multiplied by pi. So that would mean that half of the perimeter, or 180 degrees of it, would be the radius times pi. But the radius, this is 1 radius, this is 2 radius, this is 3 radius, and then a little bit of the radius, the 1,41592 part. That's pi, halfway around the circle. So what if we went the full way around the circle, you ask? Well, that's 2 pi. 2 pi. Because the r is our unit. Okay, that's like we measure the radian in terms of the size of the radius. Okay, cool. So suppose I had a circle that looked like this fine fellow, and it was 10. And then I said, what's the distance all the way around? Well, that would be 6.283,184 dot 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 tau. Okay, so tau is 2 pi. It's a different math constant, but it's just 2 times pi. Okay, we don't need to worry about that. Okay, so that is the full way around the circle. And don't you know, our conversions are going to be based on that. So if you have like radians and you want to convert them to degrees, you're just going to multiply by this little formula, right? If you've got a degree and you want to convert to radians, you multiply by the flipped version of that formula. All right? Why is that? Because this equals 1. When you multiply something by 1, it doesn't change. It just changes its units. This is a unit-based version, and this is a unitless-based version. So if I take the unitless-based version, radians, and multiply by 180 degrees, then I end up with something that's expressed in degrees. So the units can guide you on how to set this up as well. If I want to strip the units out of something, degrees, like if I have 30 degrees, and I want to strip the units out and get a unitless version, I better divide by degrees, and that'll cancel it out. So let's take some examples. Okay, so let's convert these to exact radian measure. All right, so I'm going to go 225 degrees, and I'm going to multiply. Oh, wait. I'll do one, and then you do the other two, okay? So we're going to pause in just a second. Get ready to try these. So 225, and I'm going to strip the degrees out, okay? So I'm going to go pi divided by 180 degrees. Okay? So there's my conversion factor. This is equal to 45 times, that's how many 45s? 5 of them. 45 times 5, okay? Degrees, okay? Multiplied by pi over 45 times 4. I'm just going to factorize that number and factorize that number. I certainly don't want to divide and reduce my fractions. It's the 45s that cancel. 45 degrees. So this cancels and that cancels. And then I'm left with 5 pi on 4. So that one is 5 pi on 4. And then I verify with a calculator if I want. If I'm unsure, okay? If I did 225 divided by 180, I would get 1.25. And wouldn't you know, 5 divided by 4 is 1.25. So I can check my answer that way, everybody. And then leave them in terms of pi. Don't you dare multiply that pi in. Well, I mean, you can, but people will look at it and say, noob. And you don't want people calling you a noob, okay? So now try, well, maybe you don't care. Maybe you're bigger than that. All right, try this one. Oh, you're done already? Good. I hope you got 80 degrees times pi on 180 degrees. And then you factorized that. You noticed that 4 times, wait, yeah, 4 times 20 degrees is the same thing over 9 times 20 degrees. Put over pi, and that your 20 degrees would cancel. And that this would be 4 pi on 9, or a little bit less than 1/2 pi. Wouldn't you know it? 90 degrees. I don't know why I wrote 1 pi up there. You just write pi on 2. Okay, so that one is one you can memorize, okay? It's a good benchmark. If 180 degrees equals pi, then 90 degrees is pi on 2. Amazing, eh? And that's like a really useful benchmark to have. Okay, 450 degrees. Well, what if I just one more step? Oh, wait, you try it yourself. Pause. You're done already? Good. Okay. So 45 degrees then would be pi on 4. All right. Half of pi on 2. Pi on 4. Quarter is a half of a half. Okay. So if I know that, well, I could just multiply that by 10, couldn't I? And get 10 pi on 4, which is a fancy way of saying 5 pi on 2, which is a fancy way of saying 450 degrees. Don't you feel fancy now? Isn't this so posh? Oh, I love it. Radian measure. So delightful. Okay, so 5 pi on 2. Let's just make sure. We'll do it the other way, the good old-fashioned way. 450 degrees multiplied by pi on 180 degrees. Well, I can see a common factor 90 there. This is 5 times 90 multiplied by pi over 2 times 90. And once you know it, the 90s cancel and we're left with 5 on 2, just like I told you last week. Okay, so if you have a fast way of doing it and you're confident that you're correct, that's good. And then if you want to check it a second way, that's also good. Next, so we want to be able to go from degrees to radians as well. All right, so here I want to wait. So this is approximate. So this one was approximate. We just did this. Okay, sorry. 38 degrees. So you do it. Okay, times pi over 180 degrees, and I want it to the nearest hundredth. So I'm going to actually multiply this in. So I would go 38 times pi divided by 180 equals 0.663 to the nearest hundredth. Okay, so that's 0.66. Oh man, I wish we did 39 degrees. I bet that would be 0.67. No, it would be like 38.5 or something. Okay, all right. So now try this one on your own. Pause me, and when you're ready, let's take a look together. Okay, check your work. 265. Thank you for pausing and trying this yourself. Let's just write that out. You always write it out. You always write out your formulas. 265 times pi divided by 180 equals 4.63. Well, how would we check an answer like that? Like even just like ballpark and see if we're right. Well, we know 265. Draw the picture. Okay, 265 is like that angle. Okay, very, very close to all the way around. I know this is 3.14, and this would be a little bit more than that. So yeah, that's good. That's correct. Last one, try it yourself. Good, now check it with me. 317 degrees. Then we're going to strip the degrees out, and because like the degrees cancels the degrees, right? Just crunch it on a calculator. It's just that easy. This would never show up on a non-calculator test. Oops. I can't even use the calculator for this question. It's so challenging. 5.53. These are not my favorite questions of the whole world because they're boring. These are much more interesting. Okay, so now we want to see, can we convert these from radians to degrees? Find this. All right, so 2 pi on 3 radians. Okay, well, I know that I want to put the unit back into this, so I'm going to multiply by 180 degrees. So that's on top, divide by pi. Pi cancels pi. 3 cancels 180 and makes it 60. So this is equal to 120 degrees. See how I did that? I hope you did. Okay. I wouldn't be punching pi on my calculator if I was going to type these in. I would definitely do the cancellation manually. Now, you try this one. We've already seen that one. And then see what you get. Check with me. You're back? All right, perfect. Let's go. Wait 1 second. I lost my passenger. Okay, so here we go. 9 pi on 4 multiplied by 180 degrees over pi. Pi cancels pi. 4 cancels in 180, and that makes that 45 degrees. Yes, we've seen this before. This is 225 degrees. What's that? 9 times 45 is not 225. 9 times 45 is not 225. It is what? And 9 pi on 4 is bigger than 2 pi. Yeah, this is indeed 405. 405 degrees. Check it on a calculator. Wasn't that fun watching me like fumble around? Don't you love like watching me suffer? 9 divided by 4 multiplied by 180 equals 405. Notice I didn't punch in the pies. They're not an important part of this. Well, no, they're an important part, but we don't need to like carry those around in the calculator. Like, are you kidding? Okay, 1 radian. Okay, so we have 1 times 180 degrees divided by pi. Oh, so that is it, actually. So degree measure, this is just equal to 180 degrees on pi. That's the exact value. That's the exact value. And then if you want the approximate value, 180 divided by pi is 57 degrees. Very nearly 60, but not quite. Now we want it to the nearest hundredth of a degree. So it's the same thing. I'll do the first one. Thing is, I already have 180 on pi on my calculator here. That's, you'll recall, 180 divided by pi. So I just multiply that by 0.55. And then I get 31.5 degrees. Wait, 31.5 what? Because it wants it to the nearest hundredth of a degree, an extreme degree of precision. There we go. That's what our answer looks like. Now you try this one. You're back. Okay, let's go. 2.47 times 180 divided by pi equals what for 1.5? 0.5 what? 0.52. Yes, highly accurate. Okay, and we check it. Okay, we always check our work. So we are here at like 140 degrees, not quite to, we're not quite to a full pi, which would be 180, and we're not quite to 180. So check your work. See how checking your work builds your understanding and like just makes you more fluent when you just have that habit. Okay, this one is a little bit more than 180. So I'm expecting something like there-ish. Maybe a little less than that. Yeah, no, it's a little more than that actually. Wait, no, it's pretty darn in there. Okay, so do it. Check it yourself. Make sure you can do it. 4.43 times 53.82. And there's your 253.82. It's a little bit past 240, 225. No, it's actually like more like here. Yeah. Okay. Learning. Okay, so important to remember that angles also can have a sign. Like this one looks to me to be about like degrees. Is that 45? I don't think so. Call that 40 degrees, but it's definitely positive 40 degrees. No, usually talking about that. This is like minus 40 degrees. And my guess is that this is about like 1 radian, and this could be called -1 radians. So that'd be about 1, that's a bit -1. Okay, so don't forget that cool fact. Okay, arc length. So we can use radians to calculate the arc length very simply, okay? The formula is just, you just take the angle in radians and multiply it by the radius. It equals the arc length. That's how radians do. Okay, so we know that. So what do you think we're going to do when it says the diameter of a circle is 22 degrees? Do you think we're going to draw a diagram? Yes, you're right. And then we put on the diameter, and it is 22.0. Okay, I don't know what that was going to be. But that's 22. So that means we have the central angle measures 70 degrees. So about like that. Okay. This is 11. This is 11 because diameter 22. And now we want to know this. Okay, we want to know the length of the arc. Well, this is 70 degrees. But I'm going to go ahead and convert. Oh, wait, pause. Do it yourself. You're back. Okay, so I'm going to convert 70 degrees into radians by stripping out the degrees in that way. So then we get, we're just going to use an approximate value. 70 equals. What is this equals doing here? Multiply. Ew. Okay. 70 times pi divided by 180 equals 1.222. Arc length is equal to the angle multiplied by the radius. So that is to say 1.222 times 11. I already have an example here the number here without any rounding yet. So I'm just going to multiply that by 11. Don't be in the habit of writing a number down on your page that's rounded and then working with that rounded value. Use the exact value and only punch on your calculator once. 13.439, we weren't asked for, so the arc length is equal to 13.439 centimeters. And then we'd write a sentence, therefore, the arc length. Centimeters. There. Keep going. Okay. We are told that there's an arc of 14.6 centimeters, and the angle is pi on 4 radians. I seem to recall something about pi on 4 radians. So we're going to draw a diagram. Oh, look at that. We'll draw a diagram. And we're going to put the center of the circle on. We're going to draw our pi on 4 radians. So our pi on 4 radians is there. All right, and so this is 14.6 centimeters. And this is pi on 4. Okay, so the arc length is equal to the angle multiplied by the radius. We know the arc length is 14.6, and that's equal to pi on 4 times the radius. Well, what do we do here, folks? We go ahead and multiply by 4 on pi on both sides. Why wouldn't I divide by pi on 4? You might be asking, because we're clearly multiplying by pi on 4. Well, wouldn't you know, dividing by pi on 4 is the same thing as multiplying by 4 on pi. Dividing is the same as keep, flip, change, right? So I just go straight to the changed into multiply and do that. So this is a calculator problem if I ever seen one. 4 times 14.6 divided by pi is equal to 18.589. That's the radius. So cm equals the radius. Therefore, the circle is 18.6 centimeters. How accurate? How accurate do you want me to be? I'll tell you. I'll try and remember to tell you, but I also used to don't really care. I mean, this is like, do you know how to convert? That's really what I want to see. And can you solve these types of problems? Okay, 2 gears, they work together. Oh, how good for them. Celebrate their cooperation. Okay, and speaking of cooperation, emotional support pencil case here. Right. So the smaller gear has a radius of 5 centimeters. Draw it. Okay. The larger gear has a radius of 12 centimeters. It. Determine the number of radians that the smaller gear rotates when the larger gear rotates 300 degrees. Okay, so get yourself an idea of what 300 degrees of rotation would mean. From here, it's about to there. Okay, so that's how far. So I'm really interested in the distance that goes around the outside of that. So that, I'll just put this on here. And this is theta equals 300 degrees. Okay. So in order to find out the number of radians this goes around, and it's going to go around more than once, I hope you'll agree. It goes around more than once because for every inch one moves, the other one moves an inch. Like it's a 1-to-1. Okay, they work together. As this one spins the same distance. Okay, so that's like one fact. So we want to find the length of this arc, and that's going to be equal to theta measured in radians multiplied by 12 centimeters. Okay, So let's find out theta and radians. Theta and radians is equal to 300 degrees multiplied by pi on 180 degrees, which is more a calculator question here. Okay, so, well, I can be more accurate than that. 300 over 187, 10 on 3. Theta equals 10 pi on 3. No, it doesn't. 5 pi on 3. Oof. I miscanceled. 5 pi on 3. I caught it. Doesn't count as a mistake. Okay, so if we're going to prove it, 300 divided by... Yeah. You should be able to do that without a calculator. There's 1.6. Recurring, which is 5/3. Okay, so that's correct. So now we're going to say, well, this arc length is equal to 5 pi on 3 multiplied by 12, which is the same thing. Cancel there, that's 4. So the length that it goes through is 20 pi centimeters. Okay, cool. So that goes through 20 pi centimeters. Eventually, you're going to calculate it 20 times. Oops, wondering that. 20 times pi equals 62.8, whatever. We'll get back to that. That's approximately for the 62.8-ish. It's actually not surprising because it's like tau. Okay, and then if that's also equal to L equals like 62.8, then we can work over there and say that that one's arc length is equal to, well, we can call this like, it's going to be something like that as like alpha. No, it's not good. I'm going to call that angle beta, okay, because it'll be really clear. So we would do the angle measured in radians multiplied by the radius. Okay, the radius in this case is 5 centimeters, and the length we know is 20 pi centimeters equals beta times 5. Now, go ahead and divide both sides by 5, and you get 4 pi radians equals beta. Well, that's cool. It goes through 720 degrees, or 2 pi times 2. Okay, so beta equals, well, 4 pi would be the exact answer, and that's what we would say. So then we would say, therefore, small here. Passes through. Pi radians of rotation. Exactly. 2, 4 rotations. Dun-dun-dun. Practice, everyone. Get some practice. And any questions? I'm available at lunches. And I'm available email. Email. You can email me. And you can also reach me by carrier pigeon. Okay. Bye for now, everyone. Thanks so much for joining up for the math learning.